Okay, here is part 2 of the substitution method video. We're going to do our, let's get rid of that. Whoa, sorry, let me delete that. Alright, new page. So our next example, we'll call this example 3. We're going to start with y equals 4x minus 5. And another equation, let's do 8x minus 2y equals 20. Alright, so luckily our first equation is already solved for y, so that makes it a terrific candidate for substitution. So let's do that. Let's substitute that y value, the 4x minus 5, into the second equation. So equation 2, we have 8x minus 2 times y, which is 4x minus 5. And that's going to equal 20. And we're just going to solve that. So we have 8x minus 8x plus 10 equals 20. And so that's 0, so we have 10 equals 20. Uh-oh. So our x's canceled each other out, and they are no longer here. Also, 10 is not equal to 20. So that is a false statement, which means this is a no solution problem. There is no solution. Okay, now if you remember back to the graphing from yesterday, no solution means that they were parallel. So let's see if we could have determined that on our own without substituting, just by looking at the slopes. So equation 1 has a slope of 4. I'll write that like this because it's in slope-intercept form already, so we know it had a slope of 4. Equation 2 was not in slope-intercept form. It says, what, 8x minus 2y equals 20. 8x minus 2y equals 20. Now if we put it in slope-intercept form, let's see, we'll have 8x minus 20 equals 2y. And once we divide everything by 2, we'll get y equals 4x minus 10. And again, that slope of 4 is the same. So without graphing and without substitution, if we had just put these equations in slope-intercept form, we would realize they have the same slope, different intercepts. That means they're parallel. That means there's no solution. I don't expect you to see that necessarily right off the bat. As you can see, using the substitution method works just fine to figure that out. We saw that we got a false statement, so we can determine no solution. Okay. Let's try another. So in example 4 here, we're going to have 2x minus y equals 1. And then we're going to have 3y plus 3 equals 6x. Alright, so again, we're going to use the substitution method. I'm going to name these equation 1, equation 2. It looks like equation 1 is really close to being solved for y, so let's just do that. So it started as 2x minus y equals 1. Let's add y to both sides and subtract 1 from both sides. Actually, let me do this out because I've seen some of you making mistakes by trying to do too much in your head here. So I'm going to add y to both sides. That leaves us with 2x equals y plus 1. Now we can subtract 1 from both sides. 2x minus 1 equals y. Now we are solved for y. Always plugging that into the other equation. Okay, that was equation 1, so now we're moving to equation 2. At the end of this video, you can try to see what happens if you solve equation 1 for y and then plug 2x minus 1 back into equation 1 for y, and then you can tell me what happens tomorrow. So now we solve for y, so I'm going to plug in 3. Oops, I used the same color. Oh well. I'll just use this color. So 3 times y, which is 2x minus 1, plus 3 equals 6x. Okay, so there's our substitution. Now I'm going to simplify and solve. 6x minus 3 plus 3 equals 6x. The 3's cancel, leaving us with 6x equals 6x. I'm going to get the x's on the same side, so I'm going to subtract 6x from both sides, leaving us with, our x's went away again. However, this time it's a little different because it's left us with a true statement. That is true. That means there's infinite solutions. Graphically, from yesterday, we know that that must mean that we are talking about the exact same line, meaning it has the same slope and the same y-intercept. So let's see if we could prove that just by looking at the equations. So going back up to the top, well, we could solve for y on both of them. So in equation 1, let's solve for y, which we did already. So it was y equals 2x minus 1. In equation 2, if we solve that for y, we would get, let's see, start off with 3y equals 6x minus 3. Divide everything by 3, and we get y equals 2x minus 1. Aha! Tricky. So these are the same equation. It looks different because they got the y's and the x's switched around to trick us, but these are the exact same. That's why there's an infinite amount of solutions. And that's why we get two numbers being equal. Okay? So for homework, I would like you to try what I suggested earlier. If you'll notice in all my examples, I have solved one of the equations for a letter. Okay, so in this case, I solved equation 1, and I got y equals 2x minus 1. Then I plug into the other equation. Okay, I want you to with any example you want, show me what happens if you solve equation 1 and then plug that back into and substitute it back into equation 1. Tell me what happens. And enjoy the rest of your evening.